Ever feel like the universe is this giant, incomprehensible puzzle? Today, we're taking a page from one of history's greatest puzzle solvers, physicist Richard Feynman.
Right.
Back in 1964, he gave this incredible lecture about the biggest mysteries facing science.
Yeah.
And lucky for us, it was recorded.
It's amazing. Yeah.
So we can actually listen in as Feynman himself breaks down these big questions.
Yeah, and this isn't just like, some dusty old lecture, though. It's
Right.
like a time capsule,
Yeah.
giving us a glimpse into how scientists were grappling with the universe's biggest questions at a time of incredible discovery.
Exactly. And Feynman, being Feynman, he kicks things off by breaking down what the universe is made of,
Of course.
or at least what they thought back then in 1964.
Right.
He starts with the familiar. Atoms.
Mm-hmm.
You, me, that coffee mug.
Yep.
All made of atoms.
Small atoms.
But then he zooms in closer, reminding us that atoms are made of even tinier particles.
Yeah.
Electrons, neutrons, and protons.
This was the groundbreaking stuff, the cutting edge of physics in 1964.
Yeah.
They were really starting to understand these fundamental building blocks.
But then, almost casually, Feynman throws in these other particles, like photons. Those make up light.
Yeah.
And he even mentions gravitons, which were, and still are, this theoretical particle for gravity waves.
Mm-hmm.
It's like, oh, and by the way, the universe might be even weirder than you think.
Unless we forget antiparticles.
Right.
Imagine a mirror universe where every particle has an opposite twin with a reverse charge.
Whoa.
It sounds like something out of Star Trek, but it's a fundamental part of how the universe works. This framework with all these particles and their antiparticle counterparts, that was their snapshot of the universe's ingredients at the time.
It's mind-blowing, right?
Yeah.
But it also makes you wonder, did they think they had it all figured out?
Right.
Like, okay, we found the ingredients list, universe explained.
Like we're done here.
Feynman does have a way of making complex things seem almost simple.
Like when he describes frogs and rocks as being made of the same fundamental components,
Yeah.
just arranged differently.
It's classic Feynman, but that's where things get even more interesting.
Okay.
Because even with all these discoveries, there were still huge gaps in their understanding.
Okay.
They had the pieces, but not the whole picture.
Right.
And one of the biggest mysteries centered on the nucleus of the atom.
The nucleus.
Yeah.
That's like the tiny heart of the atom, right?
Mm-hmm.
Where the protons and neutrons hang out.
Exactly.
Okay.
And while they knew what the nucleus was made of, the forces at play within it, how those protons and neutrons interacted,
Yeah.
that was a complete mystery.
Hmm.
Think of it this way. They knew the ingredients for a cake, but hadn't quite figured out how to bake it yet.
Interesting.
They knew what it was made of, but not how it worked.
Okay, so I get it. They're piecing together this incredible puzzle,
Mm-hmm.
but some pieces are still missing.
Missing.
What did they do? Well, when physicists encounter a puzzle they can't solve, they do what any reasonable person would do. They build bigger, more powerful tools to smash things together and see what happens.
The classic physicist approach.
Yes.
Smash first, ask questions later.
Basically.
All right.
And this is where things took an unexpected turn, because in the process of trying to understand the nucleus, they stumbled upon a whole bunch of new particles they never even knew existed.
Really?
Yeah. It was like opening a door, expecting a closet, and finding Narnia instead.
Wait, what?
Yeah.
More particles.
More particles.
I can barely keep track of the ones we've already talked about.
I know, right?
Okay, so instead of solving the mystery of the nucleus, they just found more pieces to the puzzle.
It's true, and you can imagine how frustrating that must have been for physicists at the time.
Yeah.
But here's where it gets really cool. Even in that particle chaos, they started noticing patterns.
Patterns? Like what?
Well, think of it like organizing a chaotic junk drawer.
Okay.
At first glance, it's just a jumble. But as you start sorting, you might group things together based on their similarities, right?
Yeah.
Maybe you put all the batteries together, then the pens and pencils and so on.
Okay, I think I see where you're going with this.
Right, so physicists started noticing that some of these new particles behaved similarly.
Cool.
They had similar masses, similar charges, or interacted with other particles in similar ways.
Huh.
It was like discovering that the universe had its own organizational system, even at the subatomic level.
So instead of just a random assortment of particles, they're starting to see families, groups with shared characteristics. It's like the periodic table, right?
Exactly.
Where elements are organized by their properties.
It's a great analogy. Just like Mendeleev brought order to the elements with the periodic table, physicists were starting to see a similar structure emerge in the particle world.
Okay.
Even without a complete underlying theory yet, these patterns were a huge clue.
Okay, that makes sense.
Hmm.
So we've got these tantalizing glimpses of order, but still no grand unified theory to explain it all.
Right.
So where do you even begin when you're facing that kind of unknown?
Well, Feynman had a rather unexpected answer to that, he said. And this is where it gets really interesting, you guess.
You guess?
Yeah.
Wait, I thought science was all about facts and experiments, not just throwing darts at a board and hoping for the best.
That's what I thought too, but Feynman wasn't suggesting blind guessing.
Okay.
He was talking about the importance of intuition and creativity in science.
Okay.
You see, sometimes to make a breakthrough, you need to start with a bold idea, a hunch, and then see where it leads.
Okay, so it's not just random guessing. There's a method to the madness.
Absolutely. Feynman was a big believer in the power of educated guesses, hypotheses driven by logic, existing knowledge, and a healthy dose of imagination.
I love how Feynman explained this. He talked about getting letters from people suggesting their own theories, comparing it to someone trying to guess a safe combination with 10, 20, 30.
Right.
He clearly had a sense of humor about it.
Oh, absolutely. But beneath the humor was a crucial point. Not all guesses are created equal. Right.
So then the question becomes, what makes a good guess in science?
All right, I'll bite. What separates a good scientific guess from, well, just a random guess?
Feynman argued that a good guess, a good hypothesis has to be more than just an interesting idea.
Yeah.
It has to be testable.
Testable.
You have to be able to design an experiment that could potentially prove your guess wrong.
Prove it wrong. Isn't the goal to be right?
Well, in science, being wrong is just as important as being right.
Really?
Because each time an experiment disproves a hypothesis, it brings us one step closer to the truth. It helps us refine our understanding and narrow down the possibilities.
So it's less about being right or wrong and more about making progress.
Exactly. Feynman argued that a good guess is one that pushes the conversation forward, even if it ruffles some feathers or challenges long-held assumptions.
Okay.
He wanted ideas that would make the universe seem a little less complicated, a little more elegant. Okay, I think I'm starting to see the beauty in this approach. It's about constantly questioning, testing, and refining our understanding, even if it means being wrong along the way.
Precisely. And Feynman used some pretty captivating examples to illustrate this.
Okay.
Like he talked about applying the law of gravity, something we experience every day here on Earth, to the scale of galaxies.
That's a huge leap.
It is, but that's how you put your ideas to the test.
Right.
You take what you know and see if it holds true in completely different contexts.
Yeah.
And sometimes it does, which is incredible.
Yeah.
And sometimes it doesn't, which can be even more exciting because it means we need to revise our understanding.
It's like Feynman is encouraging us to think big, to not be afraid to challenge the status quo, even if it means being wrong.
Exactly. And that brings us to one of my favorite Feynman moments. The flying saucer story. Have you heard this one?
Oh, yeah, it's classic Feynman.
Yeah.
He had a knack for using humor to make a point.
He really did. And in this story, he talks about the importance of being open-minded, but also skeptical, especially when it comes to extraordinary claims.
Right, like just because you see something in the sky that you can't immediately explain, it doesn't automatically mean it's alien.
Exactly. Feynman argued that extraordinary claims require extraordinary evidence,
Right.
and that even when we're faced with the unknown, we need to ground our thinking in logic, probability, and a healthy dose of skepticism.
It's like he's reminding us to keep our feet on the ground, even when our heads are in the clouds.
That's a great way to put it, and this brings us to a really profound point that Feynman makes.
Okay.
He talks about the unreasonable effectiveness of mathematics.
The what now? That sounds intense.
It is. Feynman was struck by this strange phenomenon, how these abstract mathematical concepts, these symbols and equations that we humans invented, could so accurately describe the physical world.
Okay, I'm with you so far. Math is definitely a powerful tool for describing the universe,
Right.
but unreasonably effective. What does that even mean?
It's a question that has puzzled scientists and philosophers for centuries.
Yeah.
Why does math work so well?
Right.
Is it just a tool we've created, or is it somehow fundamentally woven into the fabric of reality?
Wow, those are some big questions. It's like Feynman is suggesting that the universe is speaking to us in the language of mathematics, and we're just beginning to understand its grammar.
That's a beautiful way to put it, and it leads us to another fascinating aspect of Feynman's thinking.
So we've got this incredible tool in mathematics, but even with that, are we getting close to figuring everything out?
Right. Are we nearing the end?
Or are there still, like, infinite layers to this cosmic onion?
That's the million-dollar question, isn't it? And Feynman, ever the pragmatist, acknowledges that this era of fundamental discoveries, this feeling of pushing the boundaries of knowledge, might be finite.
Finite. You mean we might actually hit a wall where the remaining mysteries are just too complex to crack?
He doesn't rule out that possibility. It's a bit like explorers charting a new continent. At first, every expedition brings back stunning new discoveries, vast uncharted territories.
Right.
But eventually, the map, fills in.
Yeah.
That's not to say there's nothing left to explore, but the nature of the exploration might change.
I feel like Feynman always brings it back to a good analogy.
Right. And he's got another great one to illustrate this point. He tells a story about a Mayan astronomer who was incredibly skilled at predicting eclipses.
Okay, I'm intrigued. What's so special about this astronomer?
Well, this astronomer had developed this incredibly intricate system for predicting eclipses based purely on observation and arithmetic.
Wow.
He could predict these celestial events with remarkable accuracy, but he didn't have an underlying model for why they were happening.
So he had the what, but not the why.
Exactly. And when a student suggests that maybe, just maybe, the moon orbiting the Earth could explain these eclipses, the astronomer basically says, my calculations work perfectly well, thank you very much.
Wow, that's kind of a humbling thought.
Yeah.
Here we are, celebrating our scientific progress. And Feynman is reminding us that even incredibly accurate predictions don't always equate to a deep understanding of the underlying principles.
That's the beauty of Feynman's thinking. He's always challenging us to dig deeply, to ask not just what, but why. And sometimes the why is more elusive, more profound, and perhaps even more important than the initial discovery itself.
It's inspiring and a little intimidating at the same time, you know?
Yeah.
Like maybe we're just scratching the surface of what there is to know.
That's the spirit. Feynman would want us to embrace that uncertainty, that sense of wonder about the universe and our place in it.
It makes me wonder, what would he be most curious about if he were alive today?
Oh, man.
What mysteries would he be tackling with his signature blend of brilliance, humor, and that contagious curiosity?
He definitely wouldn't want us to just tell him the answers.
That's
He would want to puzzle it out for himself, scribbling equations on a chalkboard somewhere, probably with a mischievous twinkle in his eye.
You know, for someone who spent his life tackling some of the universe's biggest questions, Feynman had a way of making it clear that the journey is just as important as a destination. And honestly, I think that's a pretty great takeaway. It's not about having all the answers, but about embracing the joy of discovery, the thrill of the unknown, and the sheer wonder of trying to understand this incredible universe we call home.
Couldn't have said it better myself.